Hello students, let us start with the next module of this chapter, probability distribution. Now in this module we are going to study cumulative distribution. So let us start with the cumulative distribution. Now for that, let x be a discrete random variable. Suppose x1, x2, x3 so on up to xn is the range set of x, and p1, p2, p3 so on up to pn are the respective probabilities of values of x. Then I have this as my probability distribution, where x and px are the values for random variable and its corresponding probability. Now using this, let us try to understand what is cumulative distribution. The cumulative distribution of x at some fixed value small x is denoted by f of x and is defined as f of x is equal to p of x less than equal to x, where x belongs to R. Now this is quite complicated to understand, so let us simplify this further. What does f of x actually mean? So here in particular, f of xi is nothing but probability of x less than equal to xi, which means that I have to add, that is sum of all the probabilities for x less than equal to xi. So I can say that p of x less than equal to xi is simply equal to p1 plus p2 plus p3 so on up to pi, where I is nothing but 1, 2 and so on up to n. So it is simply the sum of probabilities up to xi. Now let us understand with the following table here and with the help of following example. I have x and p of x given as follows. X is 1, its corresponding probability is 0.2, for 2 it is 0.3, for 3 it is 0.1, for 4 it is 0.2 and for 5 it is 0.2. So this is my probability distribution. Now moving further, f of 2 we have studied just now. F of 2 means cumulative distribution for 2. So this will be nothing but it will be probability for x less than equal to 2. And this is nothing but sum of all the probabilities up to 2, which means I have to add p of x equal to 1 and p of x equal to 2. So the values from the table are as follows. For p of x equal to 1, I have the value as 0.2, and for p of x equal to 2, the value is 0.3. So on adding these, I get the value as 0.5. Now similarly, let us try to understand another value here, f of 4. F of 4 is simply equal to p of x less than equal to 4, which means I have to add probabilities up to 4. So this is p of x equal to 1 plus p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4. From the table, we can substitute the values as follows: 0.2 plus 0.3 plus 0.1 plus 0.2, and the sum will be equal to 0.8. So this is f of 4. Now let us try to take some another value, f of 3.5. So here I have a decimal value here. So what I will be doing is I will be considering p of x less than equal to 3, because x will take only discrete values, that is values at particular point only. So here p of x less than equal to 3 will be equal to p of x equal to 1 plus p of x equal to 2 plus p of x equal to 3. Now adding these, the values from the table, 0.2 plus 0.3 plus 0.1, and this turns out to be as 0.6. So this is f of 3.5. Now the cumulative probabilities can be tabulated as follows. So this is your cumulative distribution table. So here I have x, p of x and f of x, which is nothing but probability of x less than equal to small x. So here the probability distribution table is as follows. Now for f of 1, it is equal to p of 1. So it is equal to 0.2. For f of 2, I have the value as p of 1 plus p of 2, which is nothing but 0.5. For f of 3, it will be p of 1 plus p of 2 plus p of 3, which is nothing but 0.6. For f of 4, the value will be p of 1 plus p of 2 plus p of 3 plus p of 4, and this will be 0.8. And for f of 5, it will be p of 1 plus p of 2 plus p of 3 plus P of 4 plus P of 5, which is nothing but sum of all the probabilities of this event, which is equal to 1. So this is my required cumulative distribution table. Now moving further, let us try to understand what the graph of cumulative distribution function looks like. So this is the table which we have obtained in the previous slide here. So taking x-axis as 1, 2, 3, 4 and 5 and taking the values of cumulative distribution function, that is f of x, on the y-axis. So here I have 1, 2, 3, 4, 5 on x-axis, and on the y-axis the values are 0.2, 0.4, 0.6, 0.8 and 1. Now as you see that from 1 to 2 the value of f of x is nothing but 0.2. So in the interval 1 to 2 the value will be 0 to 0.2. Now as soon as the point reaches 2, the value changes, that is in the interval 2 to 3 the value is 0.5. So this point will be from 2 to 3, 0.5. As the point reaches 3, the value now changes and it enters 3 to 4. For 3 to 4, f of x will be 0.6, which is this part here. Now for 4 to 5, the value will be 0.8 as shown in the graph, and from 5 and above and ahead of that, the value will simply remain 1. So this is the graph for cumulative distribution function, and if you observe this, it looks like a step. Hence, the graph of cumulative function is always a step function. Thank you.